Okay, this is the M1 paper from June 2023. It's question number 5, and this is a kinematics question. In particular, obviously, this is a speed time graph question. There's lots of information here to have a look at, so I would suggest you stop the video and just make sure you've familiarised yourself with all the information. Okay, part A. Part A is not too bad. It says, show the distance travelled by the car between t equals 0 and t equals t is this v t minus 15. What we've got is that the car starts from rest, it accelerates uniformly up to 30 seconds, reaches that speed of v, and then just travels at that speed for the rest of the time. So if I want to work out the distance travelled, we know the distance travelled is just given by the area under the graph. So all I need to do, put that line in here and that line in here, is I've got this trapezium here. I've got that length there is t minus 30. I've got that the bottom length is t, and I've got that the height there is equal to v. So if I want to show this to the examiner, then I'm going to say that the distance travelled equals area under the graph, so equals the area of the trapezium, half a plus b times h, and that's half, one of the lengths is t minus 30, the other length is t, all multiplied by v, so that works out to be a half 2t minus 30 times v, and 2t minus 30 divided by 2 is t minus 15 times by v. So first part done. It then says, okay, we've got this motorbike which also travels along the same road. The bike starts from t equals 10, starts from rest, t equals 10. It accelerates uniformly for 40 seconds. This is key. The acceleration of the motorbike is the same as the acceleration of the car. So that means that the gradients are going to be parallel when I get to draw it on the graph. And it says the motorbike travels at a constant speed for 10 seconds and then decelerates uniformly until it reaches a speed of v. So let's see what that means in terms of... and then it asks you to draw this on the actual figure 2. So I'm going to get rid of the stuff that I had previously just because it will be in the way here, and then let's just look at the information it told me and put it on. So it says it starts from rest at t equals 10 and it accelerates uniformly for 40 seconds, and it's going to be the same acceleration. So here 10, this line being parallel to the original line, and I've got to go to 40 seconds here, so that's 10 there. That's going to be, now does it take 40 seconds or does it take, sorry, what did it say? Takes 40 seconds, so that's going to be 50 seconds there. Once we've got that, then it then travels at a constant speed for 10 seconds. That might be a little bit too long actually for 10 seconds. So let's say 10 seconds there, and then it decelerates, and it decelerates till the point, I'm going to put this dotted line in here as well, where the speed is back at v again, so that's going to be 60 seconds on there, and I don't know what this new speed is. I'm going to call this v1 and work out what that is in a second, but yep, that's good enough for the part B. It says on the figure, sketch the speed time graph for that motion. So done, okay. And then for part C, it says, can we now work out what the constant speed is going to be? So if we're going to try and work that one out, what we need to do is to realise, we'll go back up here, to realise that these two accelerations are going to be the same as each other. So I'm going to work out the acceleration for that one using this triangle, and then I'm going to work out the acceleration for the second one using the second triangle. So let's just tell the examiner what I'm going to be doing for part C, part B, part B. I'm just going to write down C graph. And part C, I'm now going to say the accelerations are the same. So for the car, the acceleration is just given by v over 30, and for the bike, the acceleration is given by that v1 that I just said over 40. Go back and look at the triangle up there. So we've got v over 30, that one over that one, and we've got v1 over 40 to work out those two, and we know that they're the same as each other. So v over 30 equals v1 over 40, so I can work out what v1 is. So v1 is 4v over 3. So that's that one there. And then it says for the last part, at time t seconds, the distance travelled by each vehicle will be the same. Find the value of t. Okay, so if I come back to this diagram then and look at this diagram, what they're saying to me is, if I consider at time t here, I'll just shade it very, really quickly, but that area there then that we've already calculated, that is going to be the same as the area, oops, put that one back in here, as this area under here now. So in order to work that out, what I'm going to do is I'm going to consider that as being a trapezium here, and then a second trapezium here, and try and work out what those two trapeziums work out to be. Now, I wouldn't suggest you draw this out again, absolutely not. I'm just drawing this out again so that we can see where I'm getting the all the values from. You do not have to draw this out again. This is purely as an explanation for you guys. I would not be doing this if I was doing it for myself. So we had, that was the first one, and then the second one basically did that, then did that for a bit, then came down to that one there. You can see how long this is taking, and we wouldn't be spending all this time, I don't think. We've got that that's V, we've got that that's 4V over 3, we've got that that's 10 there, that's obviously 0 there. What else did we have? We had that this was 50 at this point here, 60 at this point here, and this was T here. So it's this trapezium first of all that I'm going to work out. Oh, sorry. Let's explain to the examiner what I'm doing first of all. So as I say, I would not have this diagram drawn out. I just have distance for car. And we've already got that. That's T minus 15 multiplied by V. Distance for bike. And then that's simply going to be 2 trapeziums. So it's going to be half A plus B times H plus half A plus B times H. So if we're looking at this one here, what we've got is that length there is 50. We've got that this length here is 10. And we've got that this height here is 4V over 3. So that's going to be half 10 plus 50, 4V over 3, plus, and then when I'm doing the other one, I've got this length here now is T minus 60. That length there is V. The other length is V is 4v over 3. So if I put those ones in, I'm going to get half v, 4v over 3, and t minus 60. And I've just got to tidy all that up. And as I say, I've already taken quite a bit of time over this, so you guys can just work this out. What have we got? I've got 40v there when it all tidies up, and I've got 7v over 6 t minus 60 here. And then if I tidy that up a little bit more, that's going to give me 7v over 60 t minus 30v. I say, by all means, you take a little bit of time to work that out. And then we're going to say the distances are the same. So what that means is I'm going to get t minus 15, excuse me, t minus 15 times v is equal to 7vt over 60 minus 30v. Well, we can cancel all the v's out of that. I'm going to get that t minus 15, and writing, t minus 15 is equal to 70 over 6 minus 30. Apologies, that should be 6 there, 6 there. And then rearrange all that, we get t works out to be equal to 90. So t works out to be equal to 90 seconds. I'll put the units in, sorry. 90 seconds as the last part of that. That was just in case you needed more space, which we don't for that one. So yeah, quite a lot of information in that, but relatively straightforward, and certainly a good question for you to have done or seen me do, so that it will help you with future questions. Hopefully that all makes sense to you all.